Floating point instructions begin with the letter F. Now I'll go over them briefly so you'll have an idea what exists. First come the stack operations. These are the instructions that load data into the registers or copy data from the registers into memory. The FLD instruction takes a floating point number from memory and pushes it onto the stack. Now it's necessary to specify the size. If you specify double word, you get the smallest size, a 32-bit floating point number. A quad word is a 64-bit number, and a T word, a 10-byte word, is a number in the 80-byte format. These sizes refer to the size of the floating point number in memory. No matter what size you use, it winds up as an 80-bit number in the ST0 register. You can also have an integer converted to a floating point number and pushed on the stack. Once again, you have to specify the size. The source can be a 16-bit integer, 32 bits, or 64 bits, but the result is always an 80-bit floating point number in the ST0 register. And you can go the opposite direction. This instruction copies a value from the ST0 register into the destination. Now the destination can be specified as a double word for a 32-bit floating point number, or a quad word for a 64-bit floating point number, or it can be specified to be one of the other floating point registers, numbers 1 through 7. And you can also convert a floating point number into an integer. The FIST instruction converts the number at the top of the stack into an integer and stores it in the destination. The destination can be either a 16 or 32-bit number. The stack remains unchanged when you do this. There are two versions of these last two instructions, two that modify the stack. These two instructions work the same as the previous two, except the P on the end of them specifies that the stack is popped. The value in the ST0 register is popped off the stack and discarded after it is converted and stored in the destination. And there are a few special stack instructions. The FLD1 instruction pushes the number 1 onto the top of the stack. The FLDZ instruction pushes the number 0 onto the top of the stack. The FXCH instruction is the exchange instruction. It swaps the value in the ST0 register with the value in the specified register 1 through 7. The free instruction marks the named register as being available by marking it as being empty. The sets of instructions for addition and multiplication are analogous to one another. This form adds or multiplies a number from the source into the ST0 register. This form adds or multiplies the contents of ST0 into the destination. In any of these cases, the source or destination can be a location in memory, or it can be another register. These forms ending with P add or multiply ST0 into the destination, then pops ST0 off the stack. This form converts an integer to a floating point number and adds it to the ST0 register. Twice as many instructions exist for subtraction and division as exist for addition and multiplication. That's because the order of the numbers make a difference. The extra instructions perform the same operations but in the opposite order. That's what the opcodes with the R at the end are for, performing the same operation but in the reverse order. The source and destinations are the same as was described earlier for addition and multiplication.